Hi, second graders. Miss Linder here. Today is June 3rd, Wednesday. For your science topic today, you are going to be describing sound. The very first thing you are going to do is you're going to watch this video talking about sound, and then I'm going to read you, or on your own, you're going to read the Learning A to Z, the Science A to Z book. So if you do not have access, if it asks you to log in, use your Raz Kids login. So I'll read it to you. So it's called Sound. Here's a table of contents. So what is sound? Can you describe sound? You might say that sound is something we hear with our ears. How does sound move from one place to another? How does sound get to our ears? How do our ears hear sound? This book will help you understand the answers to these and other questions about sound. A thick blanket of air surrounds Earth. It is made up of particles so small they cannot be seen. Sound moves through the particles in air. You hear it when it gets to your ears. Sound is a kind of energy. It has the ability to move things and do work. Sound makes the tiny particles of air vibrate. This means they move back and forth quickly. Think about hitting a ball with a bat. This makes both of them vibrate and makes the air around the bat and ball vibrate too. The vibrations move through the air and away from them. The vibrations move farther and farther away. Wowzer! Sound moves very fast. Sound near the ground can travel at 1,200 kilometers per hour, but it moves more slowly high above Earth, where air particles are more spread out. How do waves travel? Sound moves through air as waves of energy. These waves are like water waves you see in the ocean, but sound waves travel in every direction from the thing that makes the sound. All sound that you hear comes to you as a sound wave. Sound waves are even made when particles of air are pushed together and then spread out. Each wave has a regular pattern of particles that are squeezed together and then spread out. Sound waves made by different sounds look different. Let's look at a loud and soft sounds. So loud sounds move more particles. Soft sounds move fewer particles. How sounds are different. Loud sounds come from objects that vibrate more strongly. More particles are pushed together to make loud sounds and they have more energy. Volume is how loud a sound is. Volume is measured in decibels. The graph below shows how many decibels different sounds have. The louder a sound is, the more decibel it has. You can see a jet is really loud, so it has more decibels. Sound is not just loud or quiet, it can also be high or low. This is called pitch. A little bird makes soft sound that has a high pitch. Thunder is loud and has a low pitch. In low pitch sounds, the parts of the sound wave with particles squeezed together are far apart from each other. In high pitched sounds, they are close together. Sound moves through things. You learn that sound waves move through air. They move through liquids and solids too. They move faster in liquids than in air. This is because particles in liquid are closer together than particles in air. Sound waves move faster in solids than in liquids. This is because particles in solids are closer together than in liquids. Here's a do you know? Some planes fly faster than sound. Sound waves are pushed in front of the plane. The plane makes a loud boom when it breaks through the sound waves. This noise is called a sonic boom. What happens to sound waves? It is hard to hear sound coming from something far away. This is because sound waves lose energy when they move away from the thing that makes a sound. Loud sounds have more energy. They move farther from the thing making a sound. A blue whale makes a very loud sound. It can be heard hundreds of miles away. Have you ever yelled into a big empty room? Did you hear your voice come back? If so, you heard an echo. An echo happens when sound waves bounce off hard walls. You can stop echoes by putting soft things in a room. They soak up the sound. Do you know? Dolphins and bats see with sound. They make clicking sounds. When the sounds hit an object, they bounce back. It is like an echo. The time it takes for the sound to bounce back tells the dolphin and bat how far away the object is. How we hear. Your ears are shaped the way they are to gather sound waves. The sound waves move into your outer ears. When sound gets into each ear, it moves through a small tunnel called the ear canal. At the end of the ear canal is an eardrum. It is a patch of skin that works like the top of a drum. When the sound waves hit it, it vibrates. Behind the eardrum are 3 tiny bones. When the eardrum vibrates, these bones vibrate too. The bones send the vibrations deep into the ear. A part there, called the cochlea, is filled with a liquid. The bones make the liquid vibrate. Tiny hairs cover the inside of the cochlea. The hairs change the vibrations of the liquid into signals. Thin, thread-like nerves carry the signals to the brain. When an alarm clock rings, sound waves go into the ear and vibrations are sent to the cochlea. These vibrations become signals that go to the brain. Your brain figures out that the alarm is ringing and tells you to get out of bed. Taking care of our ears. Taking care of your ears is important. If any part of your ear is not working right, you may lose some hearing. People who hear little or no sound are deaf or hard of hearing. Some deaf people use hearing aids to help them hear. Others use sign language talk. Do you stick things in your ears? If you cannot get away from loud noise, wear ear protection. Here's our glossary. It talks about a couple of definitions. We're going to go back to our slide. So now that we read the book, we're going to check out what we have to do. So we're going to look at the image right here. It has Gabby, Wade, and Tara. They're discussing the size of rubber bands and what sound they will make. So who do you agree with? Do you agree with Gabby, Wade, or Tara? Or do you think something different? So this is what they think. Gabby, I think the thin rubber bands make the lowest sound. Wade, I think the thick rubber bands make the lowest sound. Tara, I think the thickness does not matter. So if you do not have the internet, you're going to just write 2 sentences on a piece of paper explaining your thinking. So you're going to put whoever you agree with, Gabby, Wade, or Tara, and then write why you agree with them. If you have the internet, you are going to go to this Google form. You are going to put your first and last name so we know who completed it. You're going to answer the questions. Who do you agree with? Gabby, Wade, Tara, or something else? Then you're going to write 2 sentences explaining your thinking about who you agree with. Which rubber band should make the highest pitch and which rubber band should make the lowest pitch? And then you are going to press submit. And that should take you back to the slide. And then the last thing, if you have access to the materials, you can do the rubber band experiment and stretch out the rubber bands, and you can essentially try to make sound with them and see if a thick rubber band makes a high or low sound, a thin band makes a high or low sound. And make sure if you do not have access to the Google form that you are sending your work to your teacher, whether it be Google Classroom, Class Dojo, Parent Square, just emailing or texting them. If you have any questions, please reach out to any one of us, and we'll see you next time.